Good day, students. Good day, students. I am your math teacher, Mr. Kutu Endurance, and I'm here for your Google Classroom this evening. So, we are going to continue from where we stopped. So, in our last class, we were supposed to have our Google Classroom, but as a result of network challenge, the class was unable to take place. So, today we are going to look at the continuation of that day's topic. I remember I sent some slides to you to the class for you to copy. So today I'm going to continue from where I stopped as a result of time. So now we are going to look at trig ratio. We treated trig ratio. We had an introduction of sine, cosine, and tangent. So I've treated or I've sent the slides to you all to copy. Now I'm going to continue from cosine. I'm going to continue from cosine. Now for cosine of angles, the trig ratio is adjacent divided by hypotenuse. Its reciprocal is secant. Now if you look at the right angle triangle that we have, the angles are represented by uppercase letter, while the sides are represented by the lowercase letter. The angle 90 is at the angle B and the angle given is at C. Now, the side opposite the angle 90 is the longest side, which is called the hypotenuse, which is opposite B is represented by the small letter b, and the side C is opposite the angle given, which is at C, is called the opposite. And while the other side, where the angle 90 is sitting on and the angle given is sitting on, is called the adjacent. So the trig ratios of sine C, which is also represented for short as sin C, is opposite of hypotenuse C over B. For cosine C, for short, is represented as cos C, as adjacent of hypotenuse as A over B, and tangent of C, which is tan C, opposite of adjacent, is represented as C over what? A. So we are going to look at some examples of cosine of angles. All right, now let's look at the first example. So example one, we're not going to take much example. We're only going to take one example, then we'll look at tangent. Example one, find the value of the unknown side in the figure below. If you look at this question, the hypotenuse side is given, the opposite is the side facing the angle given 22 degrees, and the adjacent side is what? Y centimeter is unknown. So opposite, adjacent of our hypotenuse is cos. So we have cos. We are going to use our cosine, the ratio of cosine in our trig ratio in finding the value of y. Now let's look at the solution. Now, using the mnemonics SOHCAHTOA, so the first letter here, SOH, stands for so, which means X stands for sine, which is opposite of our hypotenuse. The other CAH, which is what? C stands for cosine, while A and H stands for adjacent over hypotenuse. While TOA, TOA, the T stands for tangent, which is O stands for opposite over what? Adjacent. So using our SOHCAHTOA, which is a short form in mnemonics to represent the trig ratios, now we are going to use it to solve this question. Now, we say we are using it as cos 22 degrees equal to which is the adjacent y over the hypotenuse 7. So making y sub to formula is equal to 7 times cos 22 degree. So using calculator, the value for cos 22 is 0.9272. When we multiply, we have 6.4904. To two significant figures, our answer is 6.5 centimeter. All right. Now we can also use what our logarithm table in solving this question. Using our logarithm table, we recall the solution, which is y is equal to 7 times 0.9272. Now, if the log of 7 is 0.8451 times what is the, we have 0.9272, what is the log? The log we have by 1.9672. So multiplication in logarithm, we are now going to add. When we add up, we have 0.8123. When we take the anti-log of it, we are going to, of 0.8123, we have 6.491. So to two significant figure, our answer is 6.5. All right, class. Now with this is just an example of logarithm. Now let's go to tangent of angles. Now, tangent of angles. Now, the ratio for tangent of angles is opposite divided by adjacent. Its reciprocal is what we call cotangent. For short, it is written as what? Cot, which is 1 over tan. So the trig ratio for tangent, recalling our right angle triangle, is tangent of C is equal to tan C opposite over adjacent, which is C over A. Now let's look at some examples. Example 1. In the figure below, calculate the value of theta and alpha. Hence, find the size of the angle at O to the nearest degree, the angle PQR to the nearest degree. Now, this is the figure that is given. We are asked to find the value for theta and alpha. Now, we have two triangles in one. So we are going to take one after the other. We are going to solve one after the other. Now, let's look at the solution. Question number 1. Solution. Using the mnemonic SOHCAHTOA. Please always recall it, SOHCAHTOA. Always recall it, SOHCAHTOA. When you can recall SOHCAHTOA, it helps you to solve any question relating to trigonometry ratio. Now, class, we are going to apply it. Now, in the first triangle, we want to find the angle theta. Taking the first triangle, that is triangle PQX. Now, the opposite side is known. The adjacent side is also, the opposite is 9, while the adjacent is 10, because the theta is facing the side 9 centimeters. So 9 becomes the side PX, which is 9 cm, becomes our opposite. And also the angle theta and the angle 90 is resting on the other line, the vertical line, which is QX, which is now our adjacent. Remember, the line facing the angle 90, which is the longest line, is always called the hypotenuse. So now, coming back to the solution, tan theta is equal to 9 over 10, which is the same thing as 0.9. When we take, using calculator, take the inverse of 0.9, it will give you 41.99 degree. Now, also, If we look at the other triangle, triangle QRX, we also use tan also, tan. So using tan, because they are both right angle triangle. Now using tan also, we now have that what? Tan alpha is equal to 23/10. When we divide, we come tan alpha is equal to 2.3. Now, to find alpha, we take the inverse of the tan inverse of 2.3, which will give us 66.5 degree. Now, class, we are asked to find the angle PQR, that is the angle at Q. So the angle at Q is the sum of theta plus alpha. So summation of theta plus alpha, we now have 41.99 plus 66.5 degree. So when we sum them, we have 108.49 degree. So we are told to put our answer to the nearest degree. So to the nearest degree, the angle PQRO is what? Approximately 108 degree. All right, class. Now, if you don't understand at the end of the class, you can ask your question during the Google Classroom. Okay, now I take more question. This is another complex one. Another complex one that I strongly believe you will understand everything. It is very clear. Now look at this other question. In the figure below, M is the midpoint of the line XZ. Now we are asked to calculate the length MZ, and also we should write down the value of XZ and calculate the value of theta. Now look at the diagram. Look at the diagram. Now let's go to the solution. From the diagram, we were told that M is the midpoint of XZ. So that means ZM is equal to MX because M is the midpoint. So using our SOHCAHTOA also, we now have tan. So we say tan, we want to find the value of what? ZM. We want to find the value of ZM. Finding the value of ZM, that will give us tan. We say tan 32 is equal to ZM over 6. So making ZM subject of the formula, we are going to have 6 times tan 32. Using your calculator, the value of tan 32 is 0.6249. So when we multiply, we have 3.7494. Okay, now remember that we said that ZM is equal to MX, the length they are equal. So if ZM equal to MX, therefore MX, the length of MX is still equal to 37.494 centimeter. All right, now, so if we want to find, from our first question, we're asked to find XZ. XZ is the summation of ZM, the length of ZM plus the length of MX. So we can add it up, 3.7994 times 2, or we add it in 2 places. That will give us at 7.4988, approximately at 7.5 degree, either to 2 significant figure or 1 decimal place. Okay, class. Now, taking the next question, we are asked to find the value of theta from the question. Now, for us to find the value of theta, all we need to do is we just have to first of all find the sum of all these angles. Find the sum of the angles X, Z, Y. X, Z, Y. The sum of this angle here, when we find the sum, then we subtract 32 from it to give us the value of theta. All right, so all we need to do now, we go back, we say, okay, we take opposite tan alpha. Let's take that whole of the angle as the angle ZYX as alpha. We will take it, taking the full triangle X, ZYX, with the angle y as alpha, with the angle at y as alpha. Now tan alpha is equal to this length. Please don't use the approximated value, always use the full value first. Use the full value. Now we have 7.4948, which is the vertical line, the vertical distance xm over the what horizontal, which is 6. Now, so when we divide, we have it as 1.2498. So to find the value of alpha, we do what? We take the tan inverse of 1.2498, which will give us alpha is equal to 51.32 degree. So to find the value of theta from the question, theta here, we now subtract 32 from alpha. Subtract 32 from alpha. That will give us now as 51.32 minus 32. So theta is equal to 19.32 degree. All right. So class, I hope with these few examples, you should be able to understand as many as you can. Now, I also have another. This is a rhombus, a question relating to a rhombus. A rhombus has the longest side as 12 cm and the shorter diagonal. The longer diagonal as 12, the shorter one as 8. Now, we're asked to find the size of one of the smallest angle of the rhombus correct to the nearest degree. This is a very simple question. Now, all we just need to do, we just look at the solution. We say let the smallest angle be theta. So look at the angle. This is the smallest angle of the rhombus. The smallest angles of the rhombus. This one is the larger ones, the larger ones. This one are the larger ones. All right. Now, if we take the smallest angle as theta, now using our mnemonics also, taking one of the triangle, we have 4 right angle triangle in the what rhombus. 4 right angle triangles. Taking one of them, now we have the smaller rhombus is divided, the length is divided into 4, 4. So the 4 plus 4 will give us 8. Why the longer diagonal, if we give us 6 plus 6, which is the what? The 12. So you can see that. Now, taking this triangle, we have 6 over opposite over what? Adjacent, which is 4 over 6, tan. So when we divide, we have what? Tan alpha over 2. Now we are dividing it because we are dividing this theta over 2 because the triangle have been divided into 2 equal parts and this other side into 2 equal parts. So that's why we have 4 triangles inside one, 4 right angle triangles inside one what? Rhombus. Okay, now taking one of them, we have tan theta over 2 is equal to 0.6667. So to find the value of theta, we say theta over 2, take the inverse of 0.6667. We now have it as theta over 2 is equal to 33.69 in degree. So to find the value of the theta, now we're told that theta is equal to, we multiply it by 2 because there are 2 here. We are going to multiply it by 2 to give us the value of theta. So theta is equal to 67.38 degree. All right, class. I hope you're following. So these are the what is a few examples I want you to treat. Okay. Now, when we meet again, I'm going to give you some class exercise for you to solve. All right, but I still have some. Although I still have some, now I look at this other one. These are your assignments that you are going to do relating to sine, cosine, or tangent. You can use any of them. Make sure they are, most of them, they are all derived from your textbook, your New General Maths textbook. Now, in this question, you have to find the value of the angle O, the value of the angle at O here, and the length AB. Okay, number 2 question, we are told that this is a perpendicular, LK is perpendicular to MN. Calculate the angle MNL. So the angle here, we're asked to find the angle here. So this is further questions also. I want you to treat them, to attempt them. When you have any challenge, feel free, you can chat me on my Google platform. All right, so this is the class for today, but that notwithstanding, we still have more class, more to treat. Now, quickly, we are going to look at the we are going to look at the next subtopic, which is complementary angles. Now, from our right angle triangle, we have that given a right angle triangle ABC with angle 90 at B. Now look at this is angle 90 at B. Now this angle 90, this is X. This is to find this other angle, we subtract X away from 90. Okay, now we are already familiar with the trig ratios of sine, cosine, and tangent. Now, using the value of X and the value as our angle. Now, assuming we want to use the value of 90 degree minus X as our angle. Now, this is what we are going to have as our result. Considering 90 minus X as our angle, so sine 90 minus X is equal to opposite of our hypotenuse, which is now what? A over B. Now, cosine of 90 degree minus X, which is what? C over B. Now, tangent of 90 minus X is what? A over C. Now, we now want to relate between this trig ratio and the trig ratio of X and the trig ratio of 90 minus X. Those that are the same. Those that are the same, that are equal. So we now want to relate them. That will lead us to what we call the complementary properties, the complementary angles. Okay, now looking at the properties, we now have that sine. If you come back to what we have here, we see that sine X, which is C over B, but the cosine of 90 degree minus X is C over B. You can observe that they are the same. Also, sine X, which is C over sine X is C over B, which is something as cosine C over B, and cosine X, which is A over B, is the same thing as sine 90 degree minus X, which is A over B. But tan X, which is C over A, is not the same as what? Tangent of 90 degree minus X. So now let's go back to the properties. So sine X is equal to cosine 90 degree minus X, which is C over B. Cosine X equal to sine 90 degree minus X is equal to what? A over B. Now, for sine X to be equal to the other one, we will now take the cotangent of X, that is cot X, cot 90 degree minus X. And cot 90 degree minus X is 1 over what? 90 degree minus X, which is what? 1 over A over C, which become what? C over what? A, the same as tangent of X. Okay, all right, class. So with these complementary properties of angles can also be also be reversed, as in cosine 90 degree minus X is equal to sine X, which is equal to C over B, to cosine X, sine 90 degree minus X is equal to cosine X, which is equal to A over B, and cotangent of 90 degree minus X is equal to tangent of X, which is equal to what? C over A. Please, let's take note of this and see when and how to apply it. All right, now let's take few examples. Example 1, we have two simple questions. Now, in these two questions, we are asked to find the value of X in the first one, and number 2, we are asked to find the value of what? Y. Take note, we are asked to find it. So we take one after the other. Question number one. Now, solution, the question is cos X plus 25 degree equal to 45. Now, by the complementary properties, we were told that what? That sine X is equal to cos 90 degree minus x. And cos x is equal to what? Sine 90 degree minus x. Now, coming back to this now, look at cos here, look at sine. So, to replace, now we are going to replace cos with 90 degree minus. 90 degree minus. So, where we have cos, because we have sine here, we are going to replace this cos with 90 degree minus. So, we now replace it with 90 degree minus this x plus 5 is representing that what? X there. It is representing that x. So we have 90 degree minus open bracket x plus 25 equal to sine 45. Now open up your bracket. Using this minus, it now become minus 90 degree minus x minus 25 degree equal to sine 45. Now, when we simplify, 90 degree minus 25 degree will give us 65 degree minus x equal to sine 45 degree. So when we divide both sides by sine, so sine and sine can cancel each other. So we now have 65 degree minus x equal to 45. So collecting like terms, we now have x or minus x is equal to 45 degree minus 65 minus x equal to minus 20 degree. So we can divide both sides by what? Minus 1. So what will be x now? X is equal to 20 degree. Okay, now we look at the second question, the second question, which is if sine 3y equal to cos 2y and 0 degrees less than y, is less than equal to y and less than equal to 90. Find the value of y. Now we go to the solution. All right. Now the same thing also we apply. Solution. This is the question. Sine 3y equal to cos 2y. Now replacing this sign with 90 degree minus. 90 degree minus. So we now say 90 degree minus 3y equal to cos 2y. So dividing both sides by cos. So we now have cos can cancel cos, cos can cancel cos. So we now have 90 degree minus 3y equal to 2y. Collecting like terms, we now have 90 degrees equal to 2y plus 3y. 90 degrees equal to 5. So dividing both sides by 5, the coefficient of y, we now have y is equal to what? 18 degree. Okay, now the last question in this is what we have now in this question, example 2. This is the last question. Now I want you to listen attentively so that you can benefit maximally in this class. So in this question, we're asked that given that sine 5x minus 28 degree equal to cos open bracket 3x minus 50 degree close bracket 50 close bracket in degree, when 0 degrees less than x less than 90 degree, find the value of x. Okay, now let's look at the solution. In solving this question, this is the question: sine 5x minus 28 degree equal to cos 3x minus 50 degree. By complementary properties, now we have, when we say sine 90 degree minus x or sine x equal to cos 90 degree. Now we want to replace sine with cos. So we are going to bring 90 minus. Now, so the 5x minus 28 is representing that x now. And so we now say 90 degree minus 5x minus 28. That is cos 90 degree minus open bracket 5x minus 28 close bracket in degree equal to cos 3x cos open bracket 3x minus 50 in degree. Now, using this minus to open up this bracket become, that is like a minus 1 to open up. So minus 1 times 5x become minus 5x. Minus 1 times minus 28 to give us what? Plus 28. So we now have equal to cos 3x minus 50 degree. Okay, so in this part, the left hand side, when we collect like a 90 degree plus 28 degree, will give us cos 118 degree minus 5x, which is equal to cos 3x minus 50 degree. Dividing both sides by cos, because we have cos in the left-hand side and in the right-hand side, in both sides. So we divide both sides by cos. Cos can cancel cos, cos can cancel cos. So we now have 118 degree minus 5x equal to 3x minus 50. So collecting like terms, we have 118 plus 50 degrees equal to what? 3x plus 5x. Remember, when a negative number is crossing equality, it becomes positive. And when a positive is crossing equality, it becomes what? Negative. So we now have 168 is equal to 8x. Dividing both sides by 8, we are now going to have 8, which is the coefficient of x. So x is equal to what? 21 degree. Okay. All right. I believe you understand whatsoever we are doing now. And I believe, God, that as you go through, as you listen over and over, you get to understand it better. Now, I want you also to attempt these 4 questions, attempt them, and send your response to me via Google Classroom. And I will attend to those that sent their question. Question 1, if sine x equal to cos 50 degree, so if you find the value of x. 2, sine 2 theta equal to cos 3 theta. 3, sine alpha equal to cos alpha plus 20. And 4, is sine alpha plus 30 degrees equal to cos 40. So please attempt these questions, and I strongly believe that you are going to excel. God bless you. I'll see you in a Google Classroom. Thank you.